This video is an intro to fractions. The first thing that we're going to look at is the 5 different ways that we are going to name or represent fractions throughout the unit. The first way that we can name fractions is we can actually think of them just solely as a number. Now, what does that mean? That means if I were to tell you the fraction 3/4, you would see it as a 3 on the top, or the numerator, and then a 4 on the bottom, or in the denominator. You don't really necessarily see it as more than just the number itself. You don't really have a picture associated in your head with that number or anything. Ideally, students will get to the other 4 ways to represent fractions because we want them to have more in their head than just the number. We want them to be able to visualize what does it actually look like. So that leads us to our second way we can represent fractions, which is by using what we call fraction circles. These are the most commonly used manipulatives in elementary schools. They are used a lot in Minnesota, especially because many Minnesota curriculums actually use the curriculum that we're going to use, which is called Rational Number Project. It's a really sweet program that was designed by researchers from the education department at the University of Minnesota. And so that's what we're going to continue using throughout the rest of this unit for us, is a lot of different stuff that they've developed. Cool thing about it, it's all free. So if you really like it, you can even use it at your future school, even if they don't have it within their textbooks. You can use it as like supplementary materials. The school that I actually volunteered at last year, that's what they did. They went away from their official textbooks for I think it ended up being about 2 to 3 months. They used the Rational Number Project curriculum and made their own little workbooks and packets and stuff for their students. And then they returned to their textbooks once they were done with fractions. They just do such a great job teaching fractions and really getting students to understand the concepts of fractions and how to do operations with fractions, fraction equivalency, ordering fractions, and so on. So it's such a great program to use. The way fraction circles work, I'm going to use 3/4 for all of these, but we would have a circle here, and that represents the whole, that our unit would be the full circle. And so if we want to color 3 out of the 4 sections, we would do that here. So I can say, I'm going to color this section, this one, and this one, and I colored 3/4 of the whole, so therefore this fraction circle represents 3/4. The third way that we can represent fractions is another type of what we call area model, because we're using some sort of geometric tool, and then we're coloring in 3/4 of the area. But this time, instead of using a circle, we use more of a rectangle, and it is called a paper strip. These are awesome to help teach equivalent fractions. We will see that later in class, actually, when we meet again next week. What I have here for us to look at is you can draw paper strips. If you don't want to actually cut out paper strips for your students, you can just draw rectangles. And then the same thing with the fraction circle. You basically want to split it into 4 equal sections, and then you would color 3 of them to represent the 3/4. So here I'd color in 1 section, 2 sections, 3 sections. That paper strip now represents 3/4 as a fraction. The fourth way that we can represent fractions is actually with a number line. We've talked about number lines in the past with whole numbers, so now we're going to be looking at them with fractions. So if I look at this number line that I have going from 0 to 1, and I want to show where 3/4 is, what I would need to do is split it evenly into 4 sections, and then obviously the third one would end up being 3/4. So that's right here on our number line. The last way that we can represent fractions in this particular class, let's go ahead and look at that, is a set model. These are by far the most difficult for students, but a lot of times this is what we end up seeing in real life. You guys may remember the carton of eggs problem from the Intro to Fraction packet. Depending on what you're viewing as the unit, that can actually be a set model, just because each egg itself could be a unit, or you could look at the dozen eggs as a unit itself and figure out which fraction is broken, if that's what you end up looking for, or cracked, or whatever. So let's go ahead for this set model. Again, I'm still doing the 3/4, so I'm going to go ahead and bring over these circles, but this time, instead of each circle being a unit, the set of 4 chips or 4 circles is used as my unit. So if I want to color in 3/4 of the circles and I have 4 circles, I would need to color in 3 of the circles. Technically, this is 3/4 being represented with this set model now. We're going to go ahead and look at some equal sharing problems now as a class. So let's go ahead and look at the example. Our first example for equal sharing problems is given to you right here. We have Ross and Linda want to share 11 cookies equally. How many cookies does each person get? I want you to go ahead and pause the video and solve this using a picture. Draw a picture of what you think an elementary student might do to solve this, and pay attention to the strategy you are using. When you are done, continue the video. My guess is that you probably did it in one of 2 ways. Some of you may have drawn perhaps like a little stick figure, and you said, well, this here is Ross, and then this here is Linda. And then what I often will have my students do is they'll say, well, I'm going to give Ross 1 cookie, and then I'll give Linda a cookie. And then I'm going to give Ross another cookie, and then I'll give Linda another cookie. They continue this process until they don't have at least 2 cookies left. Because if they don't have at least 2, they can't split them equally. Notice, after they split that, they're still going to have this one left. So what do they usually end up doing with this one? Well, they usually cut it in half. So perhaps they'll move it here. They'll take their pen and they'll say, well, I'm going to give Ross this half, and then I'm going to give Linda the other half. How many cookies does each person get? Well, let's see. We have 1, 2, 3, 4, 5, and a half. So each person is going to get 5½ cookies. Again, make sure you always label your answer. The unit is very important. If you didn't solve it this way, the other way that I often have students do it is they'll actually draw all 11 cookies out first. So keep in mind over here, this is the second way that I often have students do it. If they draw out all 11 cookies, often what they'll do is they'll still divvy them up. So they'll say, well, this one goes to Ross, this one goes to Linda, this one goes to Ross, this one goes to Linda, and so on. They'll continue this process. Oh no, now we only have 1 left. Well, we can split it in half and give half to Ross and half to Linda. Where do we actually see our answer? We go through and we count how many each person has. So here we go for Ross. 1, 2, 3, 4, 5, and a half. Notice, we get the exact same answer that we got when we did the other way. So 5½ cookies. The one thing that students would not know right away is they would not know the answer. So for those of you who drew 5½ cookies and then another group of 5½ cookies and you didn't go through the actual process of splitting them up, students would not know that. So be careful to not actually draw it that way. You don't want to draw the 5½ and say, oh, well, then the other 5½ go to Linda. That's not showing the process of actually splitting them up. Let's go ahead and look at one more equal sharing problem. This one's going to be a little bit different though, so pay attention while you are solving it. This example says 3 friends want to share 2 burritos equally. What question do you think I would ask my students to solve based on this situation? Take a minute and write down what question I should ask my students. What do you think? My guess is that you came up with one of these two questions. Either how many burritos does each friend get, or how much of a burrito does each friend get? Based on the information I gave you in that original statement of 3 friends wanting to share 2 burritos, you should automatically get a picture in your head that each friend is not going to get a full burrito. However, this is a challenging concept for students to understand, and so that's why these two questions differ. You may, in the younger grade levels, ask them the question of how much of a burrito does each friend get to kind of scaffold them and kind of guide them in the direction that the answer is going to be less than 1. If you say how much of a burrito, you aren't implying that they're going to get more than 1 burrito. However, once you get to those upper elementary grade levels, you may continue asking the question of how many burritos does each friend get, no matter if the answer is less than 1 or greater than 1, so that you aren't necessarily giving the answer away. MCA tests are really well known for doing questions like that because they don't want to imply anything for students to kind of read into. So that's why this type of question might still be asked at times. Go ahead and draw a picture again. Pause the video, but draw a picture of what you think a student would do based on either question. I mean, ultimately, we're just trying to show how 3 friends can share 2 burritos equally. So go ahead and draw what you would do. If you figure it out really easily, try and think of a second way that students might solve this, again, with drawing a picture. When you're done, unpause the video and continue. Okay. You probably did it in one of these 3 ways that I usually see my students do. The first way that I often will see students do is they'll draw out 2, they actually usually use rectangles for these instead of circles. I don't know if it's because burritos are usually more rectangular in shape, I guess. They're usually cylindrical to me, but most students will draw more of the rectangles. If you did circles, that's totally fine. Students see burritos in many different ways. So usually they start by drawing the 2 rectangles. And then the most common strategy that I get for my students to use is actually they split each of the burritos into 3 equal sections. And then they say, oh, I'm going to give this first section in each of the 2 burritos to the first friend. And then I can give the second burrito section in each of them to the second friend. And then I can give the third burrito section to my third friend. Therefore, each student would get 1/3 plus 1/3 of a burrito. Some more advanced students may even know that this is the exact same thing as 2/3 of a burrito. But based on their picture, because they did 1/3 from this burrito, and then 1/3 from this burrito, a lot of students will actually leave their answer like this when they first begin doing equal sharing problems. The second strategy that I often get students show me is they'll draw their 2 burritos, but they won't necessarily realize that they can split each burrito into thirds. So what they'll do is they'll say, well, I'm really good with halves, so I'm going to split this first burrito in half and the second burrito in half. I can give my first friend this half, my second friend I can give this half, and then my third friend can get this half. But then they get stuck. They don't really know what to do with that remaining half. So they say, well, I need 3 pieces. I'm going to split that part of the burrito, that half of the burrito, into 3 sections. And then they'll say, well, now I can give my first friend this section, I can give my second friend this section, and I can give my third friend this section. You need to be careful with how your students give you this answer. They'll be pretty good at giving you that first piece is a half. However, sometimes they accidentally call this piece here a third because they're thinking, well, I split this into 3 sections. It's not really a third though, because this half of the burrito wasn't the unit. So if you want your students to really understand what size this is, help them to split the entire unit, the burrito, into equal size pieces. Well, we would need to split this over here into pieces, and then we can see how many we have. We have 1, 2, 3, 4, 5, 6 pieces. So they receive the initial half, but then they also receive 1/6 of a burrito. Most students would not necessarily add these, especially not when first beginning those equal sharing problems. What is the last way that students will do, you ask? Well, let's go ahead and look at our last 2 burritos that I have here for us. So they might draw one of the burritos here, and then they'll bring the other one down here, and they'll say, well, I'm going to split each burrito in thirds, just like my first friend did. So this is a third, 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 and third. Now, what this student might do differently, though, is they'll go through and say, well, I can give these 2 pieces to my first friend, and then I can give these 2 pieces to my second friend, and lastly, I can give away the last 2 pieces. How much did each friend get? Oh, they got 2 out of 6 pieces. Now, this seems like a great strategy. However, what does 2/6 actually simplify to? That's right, 2/6 equals 1/3. And over here, we had 2/3. So how does 2/6 equal 2/3? How are both of these answers right? No, this student isn't necessarily wrong. Notice they haven't actually put a unit on here yet. They haven't labeled what their unit is. Think about the problem. They treated both burritos as a unit. So as long as they say that the student is going to get 2/6 of 2 burritos, so they change that unit. It's not 2/6 of a burrito, it's 2/6 of 2 burritos. This third student or this third strategy is also correct. This is why it is so important to make sure that you are using your labels to really show me that you know what the units are. Now, you may notice as I'm doing all of these fractions for you guys, I am doing everything with a vertical fraction, or basically a horizontal fraction bar, vertical fraction, and up and down fraction. My guess is that many of you over the years, I had this same problem when I was going through middle school, high school, college, and so on, got into a habit probably writing your fraction bars as diagonal lines. For example, if I asked you to write the fraction 3/4 like we did at the very beginning of this video, my guess is some of you may have written it like this. Well, now that you want to be teachers, we need to make sure that we never use a diagonal fraction bar. In fact, I'm going to go ahead and I'm going to put that here in all capital letters. Do not ever use a diagonal fraction bar. In fact, I'll even go ahead and put a handful of exclamation points after. This is so important now that you are teachers or going to be teachers. Do not ever use a diagonal fraction bar. There are a couple reasons why you don't want to do this. The first thing is in elementary school, you do not necessarily use all improper fractions. What that means is you're going to be using more mixed numbers. So if all of a sudden you have a fraction like this, 1 1/3, how many students of yours do you think might accidentally see that as 11/3? You don't know. It's hard to know, is this actually 11/3 or is this 1 1/3? If you're doing this on the board, students are going to start to copy you. They want to mimic you. They want to be just like you. And so if they start doing this, you're going to have a hard time knowing exactly what they're doing. And then that's going to lead to issues with the second thing, and that is what happens if all of a sudden I give you that you are multiplying 1/3 by 4/5. Now, I know we haven't officially learned this yet, but I'm guessing most of you still remember the algorithm for multiplying fractions. That's right, you multiply across the top and across the bottom. Well, this is really hard to see. What is the top and what is the bottom? Yes, it's 1 4 and 3 and 5, but your students, especially when they're messy and don't have the best handwriting, are really going to mess this up. So to fix both of these, we can make sure to write our mixed numbers like this. So we write the horizontal fraction bar, vertical fraction, and same thing when we're multiplying fractions. It's really easy to see, oh, we just multiply across the top and across the bottom. So please do not ever use a diagonal fraction bar on any of your problems in this class or even in your future classroom. Let's go ahead and do one last problem now that we've kind of established what we're doing with fractions. We're going to go ahead and look at this one here. We have an example of Abby, Bobby, Cindy, Dan, Evan, Frank, Gina, and Henry. That's 8 people, by the way, in case you wanted to know. 8 people basically want to share 6 cookies. Now, you'll notice on the left-hand side, I have 5 different ways that we're going to go ahead and solve this problem. They're the 5 most common ways, so I'm not saying every way that you do is necessarily one of the ways I'm going to record on this video. There are many, many ways you can solve, but I'm going to do the 5 most common ways. Go ahead, pause the video, draw some pictures, and see if you can come up with at least 3 of the 5 different ways that students might use. When you are done coming up with those 3 ways, start the video again and see if you are correct. Okay, so hopefully you had a chance to come up with 3 different ways to model this situation here between Abby, Bobby, Cindy, Dan, Evan, Frank, Gina, and Henry wanting to share the 6 cookies. My guess, and this may have been one of the ways you can put based on the burrito type problem that we did, is that some of you started by first drawing the 6 cookies. So I'm going to go ahead on my first strategy here, draw in the 6 cookies. Now, halves are the easiest fraction for students, and so because you know that each person won't get a full cookie, the most common strategy that students are going to do, they're going to go through and say, well, I can split these all in half. And then I can start to give the smaller pieces away. So maybe this one goes to Abby, Bobby, Cindy, Dan, Evan, Frank, Gina, and Henry. And yes, by now you probably realized why I chose the names I did. Looking at the 2 cookies we have left, we see that, oh no, we can't give another half to each of the people, otherwise we wouldn't have enough cookies. So what do students do? They split in half again. And then they say, oh, awesome, I have enough pieces to give 1 piece to each of the 8 people. So again, this would be Abby, Bobby, Cindy, Dan, Evan, Frank, Gina, and Henry. Now, how most students would write their answer, very similarly to that burrito problem that we looked at earlier in the video, is they say, well, each person is going to get 1/2 plus 1/4 of a cookie. When they draw the picture this way, they don't necessarily see it as how you can combine these 2 fractions. This strategy is so common that it actually has a special name. This strategy is called the non-anticipatory strategy. What the non-anticipatory strategy means is that the student didn't necessarily plan ahead. They just keep splitting in half and half again until they have enough pieces. Another strategy that students might use is they might draw 1 cookie, and then what they might do is split it into 8 equal parts. So let's go ahead and do that. After they split it into 8 equal parts, they would give 1 piece from each of the 6 cookies to each person. Now, a couple of reasons that students do this, especially with cookies or something that might have like different types. For example, you might have like a chocolate chip, a sugar, peanut butter, and so on. They might say, well, I want to try a little bit of every cookie, and so I'm going to make sure that Abby gets a piece of every cookie and Bobby gets a piece of every cookie, because I don't want to just give them a whole cookie or a whole section of a big cookie, because then they wouldn't get to try everything. So that's a really common reason why students do this. Another one is it's really easy to do the exact same thing to every single one of your pictures. Now, they may draw out all 6 circles like they did in number 1. They might do it down here and then split them all into 8 sections and then go through and label. They may do that. However, a lot of students might just do it for one and then they'd continue for the other ones. If we do this, we would end up seeing a couple of different ways. The first one is a student might see it as, oh, I get 1/8 of the first cookie plus 1/8 of the second cookie, 1/8 of the third, 1/8 of the fourth, 1/8 of the fifth, and 1/8 of the sixth. They may leave this as their answer, or because these are all unit fractions, meaning they all have a numerator of 1, they may end up actually writing this answer as 6/8 as well. That's pretty common as well. The third strategy is so similar to this that I'm going to go ahead and not even necessarily draw a picture because their picture would be the exact same. The difference, though, is going to be that instead of seeing it as 1/8 plus 1/8 plus 1/8 plus 1/8, they may actually see it as 6 groups of 1/8 or 6 cookies of 1/8. So they're going to see it more as multiplication, or 6 times 1/8. So the main difference is they're not going to necessarily see it as the 1/8 plus 1/8 plus 1/8 and so on. They're going to actually see it as the 6/8 of a cookie because they'd be able to do the multiplication of the 6 groups of 1/8. Now, the fourth strategy, and this is actually a pretty common strategy as well, so I wouldn't be surprised if many of you actually did this strategy, is they'd start by drawing the 6 cookies. And then what they would end up doing is they would, again, split them all in half. But they would realize that, hey, that's only 12 pieces, and 12 pieces cannot be split evenly among 8 people. So let's go ahead and cut them in half again. Now we're at 24 pieces. That's going to work perfectly for splitting it among 8 people. In fact, I can go ahead and give A, B, C, D, E, F, G, H. And then I can repeat the process. A, B, C, D, E, F, G, H. And then lastly, A, B, C, D, E, F, G, H. So basically, if we group the cookies into 2s, you'll see that Abby is going to get 1/4 of this group of 2, 1/4 of this group of 2, and 1/4 of this group of 2. So again, students may see it as 1/4 plus 1/4 plus 1/4 of a cookie, or they may be able to, again, add these unit fractions to get that 3/4 of a cookie. Unit fractions are the easiest for students to combine. Now, the last way that students might see this doesn't work in every situation, but it definitely works in this one. And you're going to have your creative students, your high-achieving students, and also your lazy students that are going to do this strategy for you because they're going to want the least amount of work. Now, what this strategy is they're going to say, well, if I have 8 people sharing 6 cookies, that's the exact same thing as if I split these cookies into 2 groups, 4 people sharing these 3 cookies, and then the other 4 people sharing these 3 cookies. So maybe they're going to put Abby, Bobby, Cindy, Dan over here, and then the remaining 4 people over here. Therefore, whatever they do to this group will automatically be duplicated on this side. So if they only have the first 4 people over here, they know they can split each cookie into 4 equal parts, and they can split it so Abby, Bobby, Cindy, and Dan, and they can continue this process all the way through. And then just like strategy number 4, they're going to get the same answer. They're going to see it either as the 1/4 plus 1/4 plus 1/4, or depending on, especially if it's that high achieving student, they're going to just write the answer as 3/4 of a cookie. So again, they may say 1/4 plus 1/4 plus 1/4, but they may also just say 3/4 of a cookie. Now, I told you the strategy will not always work. What makes it so the strategy works is if both, in this case, the number of cookies and the number of people share a common factor. If we're sharing 6 cookies among 8 people, those both have a common factor of 2, which is why we were able to split it into 2 groups. So it will only work, this particular strategy will only work if it has a common factor. This strategy has a special name. It is called the ratio strategy. Now, we have one more thing I want you to do to end your notes for the day. I want you to go ahead and below this, do one more example, but this you guys are going to practice writing your own equal sharing problem for 22 divided by 4. Think, what is going to be the objects and what's going to be the people or the groups? You got to make sure you do the right thing. Should your answer be greater than 1 or less than 1? That will also help you. After you have written your own equal sharing problem, I want you to go ahead and see if you can solve in as many ways as possible. You should be able to do at least 5 ways based on the notes that you just took. This will end the notes for your intro to fractions.